Alright folks, welcome back. In this video we're going to discuss yet another example of solving systems with substitution. But stay tuned to the very end because there is yet another twist in this system. So pay close attention, follow along, and let's see what happens. So here's our example. X minus y is equal to 4, that's our first equation, and our second equation is negative 3x plus 3y is equal to negative 12. So once again, we're going to solve this using substitution, which is the method that allows us to use the first equation, solve for a variable, plug that information into the other equation, find a numerical value for the variable that remains, and then go from there. So let's do that right now. So we're going to use the equation that is easiest for us to work with, so I'm going to use x minus y is equal to 4 because it's nice and straightforward. So x minus y is equal to 4, that's the first equation we're going to work with, and we're going to solve for x here by adding y to both sides. I add y to both sides and I get that x is equal to 4 plus y. Nice and pretty, and we're going to plug that into the other equation. Remember, we start with one equation, we need to plug into the other equation. So negative 3x plus 3y is equal to negative 12. That is the equation in which we will be plugging in our information. X equals 4 plus y. So negative 3 times 4 plus y plus 3y is equal to negative 12. So distributing that negative 3 times 4 is negative 12. Negative 3 times y is negative 3y plus 3y, which is equal to negative 12. Alright, now combining like terms, let's bring this 12 over to the other side. So we're going to add 12 to both sides. Negative 12 plus 12 goes away. We have negative 3y plus 3y on the left is equal to negative 12 plus 12, which is 0. And then combining terms here, negative 3y and positive 3y is 0. I get 0 equals 0. Now that looks a little wonky, doesn't it? There's no variables left. But 0 is equal to 0. This is true. This always makes sense. Always makes sense. If it always makes sense, that means there's always a solution. And if there's always a solution, that means there are infinite solutions. So this system has an infinite number of solutions. We get to this point here with substitution where we get 0 equals 0, or 12 equals 12, or something equals itself. That's always true, so there's always a solution. There are infinitely many solutions. Why? What's the rationale behind this? Let's think about it. Remember, in a system of equations, we care about where the lines intersect. In this case, what we have is actually the same line. This is the first line in red, the second line in blue. They're overlapping one another entirely. How do we know they're the same line? Well, let's take a closer look at the two equations and see. X minus y is equal to 4. Negative 3x plus 3y is equal to negative 12. These are eerily similar to one another. In fact, if I just multiply the first equation by negative 3, what happens? Negative 3 times x is negative 3x. Negative 3 times negative y is positive 3y. Negative 3 times 4 is negative 12. I get the same exact equation. So all that happens here is that the first equation and the second equation are the same. The second one is just scaled larger. So in short, if you look at this and you recognize that one of the equations is just the same equation multiplied by an integer, multiplied by a number, that means they're the same equation. That means that there are infinitely many solutions. When we're trying to solve it via substitution, what we see is that we get a 0 equals 0, or we get a 12 equals 12. We get a number is equal to itself. That always makes sense, so there is always a solution. Alright guys, check back in for more examples. I'll see you next time.